Hello everyone, welcome to my research presentation. I am Jahid Hassan, a fourth year PhD student under the supervision of Dr. Nirmal Rai. I'll be presenting my research on learning from known and unknown novel data. This work has been in collaboration with University of Maryland, Baltimore County and Army Research Lab. Human level intelligence learns local and global semantics across multiple modalities by open world observation of different categories. The ability enables comprehension of unseen novel observation while recalling known experiences. For example, we can distinguish between different novel patterns. However, traditional deep learning models are limited to a closed set setting, which assumes training and testing on predefined classes and fails to handle multiple novel categories. Alternatively, the emerging research of NCD, namely Novel Categories Discovery, facilitates learning framework to classify known classes and distinguish novel classes from realistic data containing samples from both novel and known classes. Here is a simplified objective for a novel class discovery. The function learner network aims to categorize known classes and the two novel classes in separate regions. In this study, we address the research gap of current NCD approaches and explore neuron statistics-based solutions to novel spatiotemporal action class discovery that reduces both leveling complexity and cost. To our end, we propose a novel NCD algorithm, NEV-NCD, using negative entropy and variance regularization. We experimented with two video action recognition dataset to discover novel actions. We performed extensive studies to analyze the NEV-NCD components of its loss function, architecture, dataset assumption in identifying unlabeled spatiotemporal distribution. The current NCD broadly falls under two major groups. They differ in the way they use labeled and unlabeled data. The research take motivation to explicitly achieve the data assumption. We formulate the NCD disjoint property as learning from complementary labels and fair K-phase dice statistics. We hypothesize that negative learning, explicit entropy and variance regularization would cluster the unlabeled instance, aligning them with semantics of the partially labeled dataset. Here's the overview of our single-stage NEV-NCD. The data pass through shared encoder representation and classification head that minimize traditional supervised loss and statistical constraint under Monte Carlo sampling from large batch of novel samples. We jointly optimizes learning objective of weighted cross entropy loss, contrastive loss, negative loss, entropy loss and variance regularization by utilizing both novel and known data. We have performed extensive experiment with two video action recognition dataset, UCF 101 and in-house MPSC RL multi-view dataset with three different architectures. We observe NCD in approaches outperform previous NEV-NCD approaches and supervised benchmark in both datasets. We evaluated our performance using appropriate quantitative and qualitative metrics. For qualitative analysis, we demonstrate TSNE embedding and standard accuracy and average clustering accuracy. Our model outperforms the previous approaches. We also observed that our NEV-NCD is optimized by utilizing all the losses simultaneously. In this work, we have introduced and studied negative learning, entropy and variance regularization in NCD research. We validated our approaches in action recognition. The qualitative and quantitative results demonstrate the compatibility with state-of-the-art NCD works. In future, we aim to challenge NCD assumptions by investigating the minimal constraint of novel data. We also plan to explore generalized categories discovery and over-clustering in NCD approach. We acknowledge our Army Research Lab for funding this project.